Okay, so now we're on to Module 2 that covers chapters 3 and 4, and the first video is going to be the classification of matter. So matter is the material that makes up all of the things, and it is anything that has mass and occupies space. And so what our learning objective is for this video is to be able to classify the examples of matter as either pure substances or mixtures. So matter, again, being subdivided and classified according to its composition, pure substances have a fixed or definite compositions, where mixtures is kind of like a cookie mix, right? It's going to contain two or more different substances that are physically mixed but are not chemically combined. And that'll come in handy when we talk about that specific definition here when we're talking about solutions, etc. A pure substance is classified as a type of matter with a fixed or definite composition, where an element is a compound that's composed of only one type of atom, where a compound is composed of two or more elements that are always combined in the same proportion. So an example over here is that an aluminum can consists of many different atoms of aluminum. Okay, so these are great little words for flashcards. So that you can really get familiar with the definitions. Okay. Elements are pure substances that contain only one type of the material, and some examples are going to be copper, lead, or aluminum. And we will need to know some of the common abbreviations, periodic table abbreviations. And so copper is abbreviated Cu, lead is PB, and I always think of peanut butter because it's like lead and sticks to your mouth, right? Aluminum is Al. So some of these you may be familiar with, and some of them we may have to learn, but that's okay. And so then again, when we look at copper specifically, and copper pennies, they actually are coated in copper, right? The element copper consists of only copper atoms. Moving on to what compounds are. A compound is just that. So if you think of like compound medicines or a compound, it contains two or more of the elements in a definite ratio. So an example of things that we use a lot would be hydrogen peroxide, and the chemical formula is H2O2 for that. Table salt, sodium, and chloride. Those two mixed in an exact amount is going to be table salt. Sodium by itself is very toxic. Chlorine by itself is very toxic, but together it makes some very yummy food. Sugar, C12H12 or H22O11, that would be the chemical formula for sugar, and water, H2O, we're all very, very familiar. And of course, there's a very corny dad joke, right? It's like, oh, two people went to a bar, and the customer number one said, oh, I'll have H2O, trying to be all scientific and funny. And then the person next to him said, oh, I'll have H2O2. Haha, like H2O as well. But as you can see, hydrogen peroxide is H2O2. And then, the joke is that the other guy drinking hydrogen peroxide expired. So not very funny, especially in the times of COVID, but, dorky sense of humor. When we look at elements that make up a compound, again, we're going to talk a lot about table salt because that's one that we use quite a bit. And this is a compound that contains the elements of both sodium and chloride. And when we decompose or break apart the salt, and again, the chemical formula for that is NaCl, this is going to produce the elements sodium and chloride, or chlorine. And so you can still break apart that compound into the constituent elements. Moving on to what a mixture is. A mixture is a type of matter that consists of two or more substances that are physically mixed, but they are not chemically combined. Two or more substances in different proportions, or substances that can be separated by physical methods. And so an example for this would be, this is a mixture of a liquid and a solid, and how we can separate it out by filtration. A fun thing that you can do is kind of mix sand and water, and then you can pour it through a filter, and you can see that you can separate the sand out from the water, and that would be an example of a mixture because they can still be separated, okay, by physical methods. Homogeneous mixtures, some people can pronounce it homogeneous, so either words work. So homogeneous mixture, this is the composition of that is going to be uniform throughout. And the different parts of the mixture are not visible. And so you can't see, for instance, if we're talking about that sand water, you can't see the sand floating in the water, okay? This one's homogeneous. It's homogeneous. So homo is like the same, and hetero would mean opposite, right? And so, again, I always stress root words because those are really going to help you, okay? An example of a homogeneous mixture would be brass, and that would be is because it is a mixture of copper and zinc atoms. So you can see that there's a mixture here of the copper and zinc that when combined, they make brass. Another fun one, I don't know if any of you guys have ever had the chance to go scuba diving. I tried once and I had a panic attack under the water thinking a shark would attack me because, you know, I have a phobia of fish, but that's me. So, but scuba breathing mixtures, they have to be very precise because obviously you're underwater and you need to have the right mixture so that you don't pass out and, you know, expire. And so breathing mixtures for scuba diving are homogeneous mixtures, and some examples are going to be nitrox, and this would be a mixture of oxygen and nitrogen gases. Heliox, which would be an oxygen and helium gas, and trimix, which would be all three of them together. So oxygen, helium, and nitrogen gases. And depending on how deep you're going to go and what type of diving you're going to go, you would have an appropriate use for any of these three different mixtures. And so again, here's a nice little picture of it being labeled, where nitrox is a mixture that's used to fill scuba tanks. Moving on to heterogeneous mixtures. This is a composition that varies from one part of the mixture to another, and the different parts of the mixture are going to be visible. So again, if we look and we see copper pennies in a cup of water, you can see that they're very distinct, okay? So the copper metal and the water are going to be heterogeneous. Homo, remember, was the same. Hetero is going to be opposite. Okay, so you can see that they're distinctly different. So here is a fun little table that I really, really like. And so this would be the different ways, like it's not a Venn diagram, it's a table, right? Pedigree type table, anyway, of separating out the classifications of matter. So we have matter that can either be pure or mixtures. And then under the pure substances, we have two subcategories. One would be elements and the other one would be compounds. And elements is that in its pure form, right, where compounds are the homogeneous mixtures, but it's compounded together. And then we have the mixture, which would be, so I just misspoke, the homogeneous, which is again going to be the brass versus the heterogeneous, which is water and the copper. So whether or not it's distinguishable and separatable, that's the word, easily or not. So that is a fun little table. So looking at this, let's identify each of the following as a pure substance or a mixture. Okay, we have pasta and tomato sauce, aluminum foil, helium, and air. So I'll give you guys a second. All right, pasta and tomato sauce, this would be a mixture where the aluminum foil is going to be a pure substance. We can't separate it out. Helium is a pure substance. Air, you would think, oh, well, it's pure, but remember, we have different components that are air. We have oxygen, we have carbon dioxide, and there's other different mixtures that are part of the air that we breathe. Okay, so good job. One more study check. Let's identify each of the following as homogeneous or heterogeneous mixtures. Hot fudge sundaes, which are my favorite. I happen to be up north this weekend. As you can see, I have different pictures in the background. So I'm up north, and the ice cream shop's open, so hopefully we'll get an ice cream sundae this weekend. Shampoo, sugar water, or peach pie. All right, let's guess. So hot fudge sundae is going to be heterogeneous, because we can see the distinct demarcation between the two. Shampoo is homogeneous or homogeneous. Sugar water is, again, homogeneous because it's mixed. And then peach pie is heterogeneous because we can see a distinct demarcation between the two. All right, so that's video 1.